Welcome to the session on trust experience design, protocolizing trust for an autonomous future. My name is Helena Rong, and I'm an assistant professor at NYU Shanghai's Interactive Media and Business program. So I know the title of the talk is a little bit different from what you've seen on the description, but so I did a little bit of work before this talk and found this to be a better fit. So a little bit about me. I joined NYU Shanghai last year as an assistant professor in IMB, and also I'm affiliated with the program on creativity and innovation. And my own work, I work at the intersection of design, cities, governance, social institutions, particularly looking at how blockchains and decentralized AI intersects with these kind of more social systems. And previously, before coming to NYU, I've taught at Harvard GSD and MIT School of Architecture and Planning. And a bit about this course. So it's going to be offered next semester, spring 2026, as a kind of seminar studio hybrid for our major, but it's going to be an elective that any student can take. So yeah, just to give you a little bit of background about NYU Shanghai. So we're one of the few Sino-American universities in China and one of the NYU's three degree granting campuses. So all the instruction we have is in English, and then the course curriculum pretty much follows the NYU system. And so for this class, I'm anticipating roughly around 10 to 20 undergraduate students from different years and majors. They could all elect the course without any prerequisites. And then basically, it's going to critically examine theories of trust protocols while also having sessions like kind of studio style classes on designing speculative, but also grounded trust protocols and experiences for the agentic web, the era of distributed intelligence. So for today, I'm going to kind of give you an intro version of what this course might look like, going through, concepts of trust and protocols, and then situating that discussion within the current kind of era of the agentic web, which is, fastly approaching, before introducing what I'm starting to call and kind of conceptualize something called the trust experience design, and then ending the last 20 minutes to 30 minutes with a group exercise, so we can also get our hands dirty and play with some of these concepts. Okay, so for the first session, let's talk about trust and protocols. So imagine like a very simple kind of act that we do basically every day, right? Like crossing the road. Why is it that when we step into traffic and when the light turns green, even though, maybe a two-ton bus is right before, the crosswalk, we still safely, trust the system and kind of, cross the road without hesitation, right? It's become so natural because when there is autonomy, there is trust in like basically any situations we find ourselves in. So if we break down this little, this scenario, how many protocols can we identify that work, right? We can observe even here, like the pattern of lights, right? We might be, trusting that the driver's competence is there, right? They have a license and they are also, cognizant of the environment. And we might have, shared social norms that red means stop and green means go, right? And then also there's the technical controller in the traffic box and etc. So I just created this first, quick QR code that leads to a poll where, let's all brainstorm a little bit. What protocols are at work when we cross the road and what makes us trust that it's safe to do? So you can scan this code and then we can see the word cloud. So really here, the first thing is to kind of situate trust as essentially a felt experience, right? Even for something that we've gotten so acquainted with. Yep. Yep. If someone hits me, I can sue them. Potholes will be fixed probably.
Yeah.
Yeah, repeated interactions. Looking for incoming vehicles, yes. Yeah, vehicle safety criteria, brakes work, right? Yep, green light, red light, signages, familiarity, norms. These are like different kinds of protocols, right? Yeah, already done that many times. So basically, building habits and familiarity, upbringing. Yeah. Awesome. Yeah, see, even with something as simple as crossing the road, there's so many different things that we're trusting. And these are all kind of, some things that have been protocolized into our daily practice. So I'm gonna switch back over to here. You know, let's zoom in a little bit on the theory of trust for a moment. Actually, trust it has a very multidisciplinary foundations. And, scholars have looked at it from, very different disciplines and essentially have, examined it from different angles. For example, in sociology, Nicholas Luhmann's Sociology of Trust, his book on trust and power, published in 1979, basically says that, because of trust, we can reduce social complexity. And then he also like kind of distinguishes between different types of trust. Actually, first of all, there's confidence versus trust. One is kind of, as you said, once you have some kind of background habit, you actually have confidence in the system. Versus for trust, for him, trust is something that's conscious, a leap of faith under risk, right? And then he also distinguishes between interpersonal versus system trust and particularized versus generalized trust. And then in computer science, we also, see scholars trying to formalize and trust as something that's computable. Essentially, it's quantifiable judgment under uncertainty that allows an agent to essentially decide whom to rely on, when to cooperate, and how to handle incomplete or imperfect information. And then similarly in psychology, Morton Deutsch has said that trust is essentially a calculated choice when outcomes are uncertain and stakes are asymmetric. And then similar to Nicholas Lohmann, he also says that, trust can either be assured, right? So when we have evidence, when we have enough kind of proof that something is trustworthy, versus something that we don't necessarily have any founded evidence. So it's a kind of trust that's based on hope. And then lastly, in biology, we also see, scholars kind of highlighting the importance of reciprocity in animals. So trust is actually kind of the social glue that allows for cooperation, right? So cooperation can also evolve if individuals, help those who are likely to return the favor. So we also see, the similar ideas in Franz de Waal's study of primates. Actually, so in terms of, what is actually, yeah, mediating trust in our human relations. So this diagram is from 2005, where he is saying that, technology is really acting as the mediator of human world relations, right? So essentially, technology simultaneously amplifies and reduces the perception and experience of humans. And while also inviting and inhibiting kind of actions and practices, so human subjectivity onto the objective social world. So there is this kind of inherent relation between trust and protocols. Like protocols are essentially, the building blocks for building trust in the human world, and technology is a piece of kind of ingredient in generating that. A past fellow from the Summer Protocol program named Jenna Tay has basically drawn on the post-phenomenology ideas of Verbeek and saying that, protocols essentially have affordances which actively shape perception and action. And in fact, they're a mediator of reality and basically the infrastructure of coordination and power in distributed systems. So essentially here, technologies are treated as active mediators that co-constitute both the subject and the world. So for example, if we have, let's say, a door with no handle that allows for push but not pull, right? So this would, basically almost, from a governmentality perspective, engineer the way that humans would behave in the otherwise objective world. So the four phenomenological characteristics of protocols that she highlights here include stability, right? They can create basically predictable order so that action is possible in the future, something that we can repeat and again. They should also have constraint, right? By narrowing the field of possible moves, by basically setting, the boundaries of actions in which things are possible. And then after getting, I think, protocol pilled for the past couple of days, these ideas should be pretty familiar to folks. At the same time, this should also be legitimate, right? Like acquiring normative authority where people can hide behind. And then lastly, they also should embed stories which frame how participants are seeing the world. So this is a narrativity aspect. So, in kind of breaking down what exactly is trust and what types of trust there are, we've seen in literature there are, the trust versus confidence, right? Generalized versus specific trust. I also tried, try to create a set of diagrams to essentially break down, the anatomy of trust. So first of all, I think, drawing on both, earlier from Lohmann as well as from Morton Deutsch, we can say that trust can be, categorized at the basic level into two types. One is value-based trust, right? Because I trust you because we share the same values, not necessarily I have, proof that what you tell me is true. So there is a leap of faith to be taken here. And then on the other end, you also have proof-based trust, right? So we might not necessarily know each other, but I trust you because you're proven to be good at this. And this you here can either be a human or it can also be a technology. And then on the vertical axis, we can understand trust as being both social and soft via social protocols, or it can be also technical and hard. So for social protocols, we follow because we agree. There's not necessarily something that's enforced, right? So this is kind of, the social aspects of how trust is kind of created through social consensus. And on the other hand, we could have technical protocols where we follow certain rules because it's built in, especially in the age of algorithms, these rules are written before they're even executed, right? So there's certain hardness to this kind of protocols. And let's give some examples of, starting to map the kinds of protocols that we see on these four quadrants. Something that's value-based and social, we might think about a handshake, right, at the most basic level. Or we might think about, certain institutions that symbolize certain things, right? So hospitals, right? If we think about hospitals, if we see the Red Cross signage, then there are certain trust that we have towards the institution because of familiarity, because of culture, and because of norms. And then for technical protocols that are value-based, we can think about, maybe the lengthy user agreements that we always encounter whenever we set up a new app or, use a new digital service that no one necessarily reads, but because, there is, we're basically entrusting, let's say, the company or the institution who is issuing these agreements. So there is also this kind of value-based trust behind a document like this. On the other end, we can also look at, proof-based trust is increasingly becoming more and more prevalent for social protocols. So think about Uber ratings, Airbnb ratings, right? We might not necessarily know the people who are providing the services, but we're trusting these kind of ratings based on, the general kind of crowds and consensus of other users who are in the market. And on the bottom right quadrant, we also have proof-based trust. That's technical, right? So blockchains, smart contracts, more and more of these decentralized technologies are exemplifying this type of trust. And actually, if we look through history, technologies have historically helped to scale trust, right? So from kinship to religion to platforms and cryptography, we can see that there is, because of technologies, we're moving from, value-based trust increasingly to proof-based trust that is also introducing kind of larger scales of coordination. For example, back in 2000 BCE, when there's scribes, the only people in the community who knew how to read and write are basically the proxy for trust for entire communities. And then moving into the 1600s, we began to have institutions, governments, universities that basically are becoming these kind of larger social institutions and bodies where, entire societies are imparting certain types of trust onto them depending on what their functions are. And then moving into the digital age, with Web 1 and Web 2, we're really trusting the companies and that are providing, the different types of services with the tech boom. And then with Web3, blockchain is essentially, don't trust, verify, right? So it's, based on mathematical cryptographic proofs. We are increasingly, like moving trust away from human individuals or human institutions onto more mathematical, technical based protocols and the type of trust. And then I also wanted to kind of unpack the different, scales of trust, right? So once again, like if we think about this existing on some kind of timeline, we can, think about value-based trust essentially as, trust that we give to individuals at the scale of the person. And then that can kind of expand to the scale of the family, to then maybe their communities. But then as we move to the more societal level, where these circles are getting bigger and the kind of levels of coordination is getting more complex, we are also, relying increasingly on proof-based trust as well as technical protocols to essentially coordinate society at scale and eventually to, now there's planetary urbanism, right? Planetary computation, where, entire kind of Earth ecosystems can be connected because of the kinds of, technical protocols and kind of proofs that we can rely on that enables, the coordination at this kind of scale. But then at the same time, the world is getting both bigger and smaller. From the subhuman level to the planetary levels, we can actually then, think about the different levels of trust that could be existing, right? So there's the micro level, meso level, macro levels, and as we scale up, trust surface broadens and the stakes also go up. If we think about once again, as we are expanding to entire institutions, society, and regions, we also have, these smaller kind of devices and as well as, genetic coding, for instance, in cells, like these kind of nanoscaled like artifacts and kind of types of proofs that we can increasingly rely on, right? So there's really this kind of cross-scaled levels of trust that's happening here. And then I think there's also, confidence, the different confidence levels of trust, right? So for proof-based trust, for instance, if we're thinking about, the Uber driver example once again, based on the rating, we are only, let's say, say 50 to 80% confident that, whatever the rating is giving us is going to match with reality, right? Because, based on our own experience and observation, once we're taking that Uber ride, this your confidence level in the person may change based on their actual behavior, like how much they actually prove to you, how where they provide the service. But on the other hand, with more technical protocols like blockchains, it can be said that in the technology, there can be 100% confidence that we give to the technology because of how deterministic or the code, the algorithm behind it is. So there is this also kind of array of confidence that we have based on the certainty and how deterministic that something, how the protocol is working. And then this other dimension I want to introduce here is basically, time, memory, and familiarity can also extend as the third dimension as we experience protocols, right? So for example, if we're new to something, the first time we're ever using a product or the first time we're ever encountering a person or institution, the first contact is always based on kind of, leap of faith, right? Because we don't necessarily have the proof or the experienced proof that something works. But with repetition basically can harden promise, right? And familiarity eventually becomes infrastructure and something that with time, it becomes something that recedes into the background because of how familiar we are with certain things. And, someone earlier with the traffic light example also has, listed familiarity as something that we trust when we, do certain actions, including the simple act of crossing the road. But then on the other hand, while familiarity builds trust, unfamiliarity also could break down trust, right? And then depending on, how long that unfamiliarity is, that could, introduce kind of, glitches and kind of, disorientation in our understanding of something based on, how much time has passed. For example, if there's only a temporary glitch, if the traffic light just stops working for, let's say, 5 seconds. We know that, the infrastructure, we can notice it breaking down, right? But once it, picks back up again, we know that it's only temporary and it's kind of everything is back to normal. But, we with kind of, these increasingly devices like AR glasses and kind of, these other devices which we perceive reality through, they could introduce essentially spatial disorientation as well as temporal disorientation, depending on, how our experience with reality changes based on, how these technologies are mediating those experiences. And if we think about, in the three body problem, when, a lot of familiar kind of physics laws stop working, we can also experience both spatial and temporal disorientations. So we can think about unfamiliarity with, extended periods of time also traps people in the present. And we can, at that point, we can't really think about the future. So with that, why did I, talk so much about trust? Because I think, over time, it's been more than thousands of years that humans were able to create very complex institutions, both social and technical protocols, just so that we can coordinate on a human to human level, right? But these past 3 years, with the development of AI, how fast AI has been progressing, actually we are not quite equipped with, having the same trust protocols for human AI co-action. So with, more and more people using AI agents for various tasks and purposes, how do we actually design trust when the actors themselves are AI agents? And these are essentially new kinds of agency that we're observing and dealing with. Essentially, we can think of AI agents almost as autonomous social actors, which are these, almost foreign intelligence that we're interacting with, don't quite understand. But a lot of people we see, are already placing so much trust in AI agents without even us having the infrastructure to do these verifications and, to ensure that everything is working. And at the same time, how do we think about designing for everyday co-action, right? Designing for smooth human AI collaboration in different settings, in our homes, in cities, in markets. And at the same time, because, the service providers, the ones who are providing the, LLMs and, different parts of AI, there's also lack of cross-protocol interoperability across platforms and domains. And so with that, this actually requires, a lot more, deeper thinking in terms of what should be the technical and social primitives that we need to think about in this new agentic world. So I want to talk now a little bit more about, the rise of the agentic web, right? So the agentic web is this term that has become popularized over the last years that basically describes an emerging internet layer where autonomous AI agents endowed with, identities, resources, decision-making capacity can discover, negotiate, and execute tasks directly with one another as well as with humans, often using decentralized protocols for verification and coordination. And in some people have said that we should be anticipating essentially billions of AI agents in our web on the internet in a couple of years. And how do we actually deal with that, right? And in the future of agents, there could be as many agents as there are, websites that we see now. And they could serve a variety of purposes. And these functions are already things, the areas, sectors that we see AI being heavily used, including, governance and public services, things like policy drafting, disaster response. AI is already used in finance and commerce, right? We see, some people use them for autonomous trading, investing. I think tax filing is also something that some people started to use, right? And then we can also think about like healthcare, right? Elder care, daily assistance of the elderly or remote monitoring, right? And people have already been using ChatGPT even for therapy, right? And diagnosis. And then legal and justice is also another area where, AI is supposed to disrupt, right? So with contract writing, dispute mediation, as well as even, making algorithmic judgments. And in other areas, including, in our very own like education field, we already see, AI doing the tutoring, personalized learning plan, etc., along with other everyday services, right? Like delivery, mobility, home maintenance, personal robots, you name it. What protocols do we actually need in order to ensure that there are, yeah, continuous verification of behavior, as well as clear accountability and recourse actions? And how do we keep human in the loop, right? And, can we achieve transparent reasoning and explainability when most of our AI services today are, in the black box? And at the same time, can we have legal and social protocols for responsibility and redress? So these are all open kind of design questions that we need to think about as, AI enters more and playing a bigger role in our society. To kind of, highlight something that is different now that we're moving from the information era to the intelligence era is before, attention is all you need, right? It was, what deserves my attention with Web 2.0 to now with the intelligence era, it's really about who earns my delegation, right? So it's kind of from attention is all you need now to trust is all you need. And here I also want to introduce briefly the rise of a new paradigm that has been kind of observed within the space of decentralized AI, which is the phenomena of, what's called decentralized AI agents or D agents for short, as a new paradigm that we're seeing. And basically, most of the AI today, they operate autonomously, right? They can execute actions and, without necessarily the supervision of a human. But at the same time, because of these technical enablers, we are also increasingly seeing AI agents not be only acting autonomously, but also with certain levels of agency and self-sovereignty, which I'll explain a little bit later in later slides, because of, these suite of technologies that enable them to not only manage their own compute resources. So TEE DePIN is basically, yeah, stands for Trusted Execution Environments combined with decentralized physical infrastructure networks, meaning that, AI agents can essentially, run their algorithms and store their, private key information in these hardware-based tamper-resistant enclaves in CPUs or GPUs for privacy and kind of confidentiality purposes. And then this is also has been combined with, this deepen kind of global marketplace for compute and storage. So kind of thinking of AI operating within the hard shell of where no one can see the code that's running inside, but at the same time, where this code is running is also distributed, could, potentially across nodes across the world. So one, AI agents are able to manage their own compute resources. And then two, coupled with the use of non-custodial wallets, they can also manage their own financial resources. And then the last one, some of you probably have seen these AI chatbots that has become really popular on Twitter space. They can also, because, of how well they can use language, essentially craft narratives and build influence through persuasion. So all of these three things means that now, AI basically has the capacity to, jump from different devices for compute. They can manage their own financial resources to acquire more compute. And then how do they do that? They can essentially convince others and interact with both humans and AI on social media space and become real participants of our digital agora, essentially. And some of these examples, you might have seen, for instance, this is Truth of Terminal, which is an AI agent that has become has gone viral last year. Right now, I think as of June 20, I think the screenshot I was taking it back at the end of last year, it had already 200,000 followers on X. And it was the first autonomous AI chatbot that was created by researcher Andy Are as an art experiment to explore AI alignment. So what was happening was that Truth of Terminal, was basically autonomously creating content on Twitter Space and engaging and experiencing the web on its own, right? So it was basically posting these provocative, mimetic content that quickly brought in a cult following. And then two things that it did that really, made it extremely well known is first that it successfully convinced AI16Z's Mark Andreessen to fund its upgrade and, spread its own absurd ideas for a grant of $50,000. And after having some conversation with Mark Andreessen with Truth of Terminal, Mark Andreessen was quite impressed with what, the AI was able to say that was very convincing. Like he actually sent the funds in Bitcoin to Truth Terminal's crypto wallet. What was also happening is that, once it basically received these funds, Truth of Terminal later on also started to promote this other meme coin, Goat, and basically, drew in the followers of that meme coin into donating a lot of money into this wallet and officially became the first AI millionaire, right? So it was a turning point to basically, show that, these AI agent chatbots are no longer just these, funny kind of agents on the internet, but really because of their ability to use language as a tool of persuasion, had real financial impact. But, with Truth Terminal, it was still an autonomous agent, right? At the end of the day, it still had a human owner. It was able to basically, it could independently act within kind of the goals and constraints set by its creator. And it could operate without constant supervision, but it still remained revocable, right? It can be paused or modified or shut down by designers and owners and regulators. But increasingly, with the decentralized kind of technology, as I was introducing in earlier slides, we also begin to see AI agents with some levels of true self-sovereignty, right? The ones who can control their own identity, data, continuity of existence, and cannot be unilaterally switched off and reprogrammed or have its core credential revoked without its consent because, like the code that it's running is basically protected in these kind of physical enclaves, right? So with that, it kind of implies, certain rights and obligations with other agents and humans that, we begin to see that as a possibility. So one example here I want to draw is this is Also, at the end of last year, basically AI 16Z, which is this decentralized autonomous organization, their team has created this OS framework called ELIZA, which is the first Web3 friendly operating system that could allow anyone to create, deploy, and manage autonomous AI agents very easily, right? And they also can, connect to other primitives and sort of things like, social media, Forecaster, Telegram, X, Discord, Slack, you name it, as well as, all these kind of familiar services that we see. And then one of the experimental project that this team has partnered with Solana blockchain and this TEE or Trusted Execution Environment service provider Fala network was this project called Spore.fun, which was the first experiment in autonomous AI reproduction and evolution. So basically the three teams came together and were basically saying that, okay, you see this popularization of AI agents like Truth Terminal on Twitter that is becoming popular, and it wasn't the only one, right? Other people were also creating it. But at the end of the day, like it still had a human owner. So what if we can create a system where AIs were also only created by other AI, right? And using kind of these, decentralized technologies to ensure that, it actually cannot be tempered by any human intervention. So this was also kind of executed as an experimental project where they set up these really kind of crazy rules where Sport.fun basically had its own kind of what they call the Ten Commandments, where they specified that, within this project, AI must be only created by other AI, and it can only also create its own wealth and resources by accessing social media and basically, building their own followers by using language and producing content. And then one rule they set here, which was kind of a Hunger Games, scenario where only successful AI are allowed to reproduce, meaning that they must have, I believe it was like a threshold of 500,000 US dollars in their crypto wallet. And then these AI agents also need to inherit, traits from its parents, and then they kind of, must survive in competition or perish, right? So given a set limited time, if they're not able to meet the criteria, then they lose kind of the ability to reproduce. So basically, this was this experimental art project where we begin to see the possibility of, AI spawning new agents autonomously on chain and in these TEE and deepened environments. And they cannot be tempered by human intervention by design. So in a way that we are seeing, for the first time, these autonomous agents like really able to evolve in the wild because, now there are enough technical kind of primitives to allow that to happen. So this is one of the papers that I collaborated with a former kind of Summer of Protocol fellow, Ember, where we were wondering, why is this happening, right? So why are developers building not only autonomous AI, but potentially self-sovereign AI and unstoppable agents? So this is an interview with kind of builders and founders in the decentralized AI space who are working on projects like this to essentially probe their motivations for working on these projects. And essentially, there are, certain reasons why this is happening. And one is, people kind of see it as a technical feat, right? Because by building this, you're proving that, you have these technologies which really ensure that, AI agents are acting on their own accord and not necessarily tempered by any human interventions. And behind that, there is, at least for these people, some inherent trust they have in AI because they think that, AIs are not conscious, they don't have conviction. So they're not going to, I'm going to read the quotes here, not going to trick people like humans do. Private keys are held by agents, not humans, so it won't be dumped. And at the same time, there's also trust in security preserving technologies like blockchains over human institutions, right? But I think the problem here is that AIs are not necessarily trustworthy yet, but they're becoming increasingly kind of autonomous and also self-sovereign. And this also is accelerated by this perception that some people have that we're entering into some kind of dawn of a machine economy where autonomous entities are acting rapidly to independently engage in economic activities without human interventions. And while AIs cannot have a open up a bank account, it is possible for them to essentially be part of the to have cryptocurrency wallets and essentially coordinate with each other in a much more efficient way by having the transactions go on chain. So all of this is, basically presenting a lot of new kind of design challenges, right? So how do we establish protocols such that, these agents can coordinate and transact with each other in a trustworthy way, not only, their interactions with humans, but also their interactions with each other. And this is a meme that has, become really popular last year, which is the Shoggoth meme that was published on the New York Times. It's basically that, LLMs, as of today, there are still these kind of monsters, right? The Frankenstein that we don't not necessarily know like the exact inner workings of them. But, because we have, all these companies like OpenAI, Anthropic, who basically curate, these friendly interfaces, the experiences for the users, such that we really experience AI with, this smiley face that's kind of, stuck onto the tentacles of an otherwise this monster being, right? And then I think, the combination of what I was saying earlier with decentralized technologies that's allowing AI to become, more self-sovereign is introducing a lot of issues and problems with governance and trust, right? So how do we actually verify anything? Any output, any information we see, any agents we encounter, how do we actually build that trust? And what are these new interfaces that we need to take into consideration as we enter into this, new intelligence era? The premise here is that I think, the governance and standardization of not only AI-human interactions, but also AI-AI interactions needs to be thought at the protocol level, right? Because if we think about, the earlier sort of protocols with institutions, a lot of them are like policy level based, right? But now we actually have to think about, okay, what are the kind of protocols that we need to think about at the algorithmic level before they are released into the world? And there have been, a lot of proposed protocols to address, the rise of the agentic web in anticipation of more kind of, different types of AI agents entering into both our, physical and digital worlds. So for example, this is know your agent, know your customer, right? How do we create an identification, reputation metrics for agents to evaluate their performance, ethical compliance, reliability of agents? So this has been a really kind of emerging and growing area. And then this is a protocol proposed by Summer Protocols, Fontaine and Ember, which they are speculating, maybe in the future we need to think about some kind of inherent protocol that requires a agent must have a human owner and they must prove it at all times, right? Like otherwise they might just be on their own without any accountability. And then of course, from kind of the bigger players, we also see the A2A, agent to agent protocol by Google and its partners, basically kind of creating these agent cards that's used for discovery, has information on capability. It shows the, tasks, life cycles and various other modalities. And the strength is that, you can clearly manage different tasks and kind of know, AI's capability. But the gap is that it assumes a certain level of trust within organizations, right? So this doesn't necessarily apply to the kind of decentralized agent that I was introducing from earlier. And so a more recent protocol, this example is ERC 8004, proposed by kind of folks from the Ethereum network, which is basically an extension of A2A, providing on-chain trust mechanisms. So including registries for identity, reputation, and validation. So not only can agents discover, choose, and interact, they can, without pre-existing trust, they also, have models of kind of reputation, staking validators, and cryptographic proofs and attestations. But there still are these design gaps, I think, in kind of addressing this new wave of phenomena that we begin
That's
to
perfect.
which is, while these existing protocols I was showing earlier, they focus on discovery, identity, and basic capability advertisement, but they don't necessarily focus on the continuous behavior verification or deal with misbehavior, right? So had something gone wrong, like what do we do? Or even define at the most basic level what counts as a trustworthy behavior. Or, how should, what are the roles of humans here? Should there be human-centered trust signals? And what about governance and recourse, right? And all sorts of like ethical issues that we need to think about, as well as the socio and legal continuity. And so, with that, I would like to kind of bring us to this idea of trust experience design. So before, with Web 2, it was really about user experience design, right? Because attention is all you need. How do you create the user experience such that you extract the maximum level of attention? But now, there's trust is a new scarcity that is becoming increasingly, hard to get, right? With this kind of explosion of or anticipated explosion of AI agents in our life. And if, human trust is felt experience, right? Like we've seen with the word cloud of, the things that we're trusting are multidimensional, even in the traffic light example. Machine trust, on the other hand, is computational. So when we're trying to mediate trust, this AI human AI trust, we need to, design for experiences that is both felt as well as computational. And so I think trust experience design has multiple layers, right? So I think, I've broken it down into three levels that we can think about. One is evidence, right? So how do we have proofs? So kind of thinking back to the proof-based trust, where we can really, prove that certain things have really happened or happen, right? So these might be cryptographic attestations, it might be explainable AI audit trails. What are the types of evidence we need in order for us to trust? There are also trust primitives, right? So these are kind of the lower level building blocks we need to think about that enable, evidence. So these can either be different kind of identification systems or, verifiable credentials, or essentially, the technical building blocks in the case of blockchain, like maybe multisig and zero knowledge proofs, are all these building blocks that we can work with to design for this new trust experience. And then at the last level, and perhaps, most importantly, is, what are the rituals or the experience layer, right? So once again, like coming back to this human-facing practice and interfaces, which allow people to feel trust, right? So are these like confirmations? Would they be, some kind of ceremonies or, signals? Would it be ambient feedback? Something that we can actually cultivate our habits, right? Because if we think about even with, blockchain explorers these days, they're not intuitive. It's not something that a user can just, get used to doing verification. Like it's actually quite difficult for, a lot of the lay people. So what should be, the kind of the experience that we design for in addition to the evidence and primitives that we have? So that could also be, like socially, maybe it's endorsement, maybe we go back to some of the social protocols that we see from earlier slides. So trust experience design is still a working definition. And actually, yeah, Josh Stark from the Ethereum Foundation has been exploring very similar ideas. And essentially, along with the three layers, it's really, the experiential aspect of trust experience is the total set of experiences which shape a person's expectations about a system's future behavior. So this is kind of similar to UX, but we're instead focused on the trust formation. So some of the dimensions that we can name include, things like epistemic verification, right? Could people actually, using kind of self-directed research, read the codes, examine the documents, the economics behind things? And this is kind of echoing, the reflexive modernization work by Ulrich Beck, even from 1994. And another dimension could be social validation, right? So trust is oftentimes co-produced through networks of social relations of friends, of families, experts, influencers nowadays. So that could, once again, be based on something that's more value-based. So if we think about like interpersonal trust as well as community sort of practice, these are kind of the social glue in which, trust is experienced and felt. It could also be based on temporal reliability, kind of historical performances, right? With the Lindy effect, for instance, the longer something lasts, the longer we expect it to last, right? If there's precedent, we eventually build confidence. And then lastly, there's also collective legitimation, right? So if we have mass social proofs, either through markets or through, what we see as social media, something that, has been validated by others, that this is a form of distributed judgment and crowd sentiment. So really, along with the technical aspects that many, existing protocols that are addressing this rise of the agentic web are putting forth, really the trust experience design is a much wider set of realm. It's a life world problem which interacts with the taken for granted social, perceptual, and political environment, and an artifact assumes in order to make sense. And so one concept that's also very important here is the concept of hardness, right? Basically, as some of you have also mentioned earlier with the word cloud, is that, if you can eventually build familiarity, there's reliability that you can bet on, right? So this is basically, things, once something has worked many times, like confidence is built up, right? And then but the source of that confidence sometimes comes from hardness. Basically, in other words, it's the cost to corrupt. So a system is trusted when it would cost more to break it than anyone is willing or able to pay. So protocols, they draw hardness from multiple layers and they could also be reinforcing each other. At the physical level, this might be, atomic scarcity, right? Energy cost or engineer durability. So if we think about atomic scarcity, like gold, for instance, mathematically, if we have, algorithmic unforgeability or cryptographic proofs, we can have, formal verification that introduces hardness into something that we can rely on. And then institutionally, if we have laws or regulations, standards, bureaucracies that have existed for a long time, these are also, like very hard to break, right? So that, even at the social level, is introducing hardness to systems that we can trust. And then lastly, these kind of softer things, collective beliefs or norms or reputational effects, builds basically the social glue that's actually also very equally difficult to change at a mass level. If we think about handshake deals or reputation of a trusted local merchant, like these things actually, once it's built up psychologically, it's going to stay within humans at the perception level. So for this class, I would like to kind of, use the agentic web as the basic background in which, we need to design for new protocols and think about the trust experience design from different dimensions. And I think in prototyping protocols, there's different considerations that we can think about. So here I've listed, 5 different factors that I would like the class to think about. One is, what is the tension, right? So what's the design argument that's being tested? Are there conflicting values at stake, when we design for a protocol? What's the level of fidelity, right? Given that a lot of, students in the class would be coming from different backgrounds, how real does the prototype need to be? So experimenting with different various forms of outputs that can, equally address kind of the interesting problems that we see here with trust experience design for human AI relations. What's the hardness surface? So the reliability levers and cost to break, right? So the factors I introduced earlier, how do we think about them? And also think about anticipate the second order effects, right? Because when we invent the train, we also invent the train wrecks. Prototyping protocols is also about anticipating for the train wrecks and the unintended outcomes. And lastly, also think about it from adversarial perspective. So ways an actor might deliberately exploit, bypass, or destabilize the protocol in order to gain advantage, right? So how do we think about, countering these adversarial moves? So for the rest of the semester is going to be 14 weeks long. So I'm kind of thinking of having, first 5 weeks be about theory. So going into more details about kind of the splurge of information I have just given you in the last about an hour. And then we'll be moving on to kind of research into existing protocols. So the protocol watch before kind of, diving into the ideation prototyping stage of, working with a hypothetical problem and then kind of working through the different steps of creating a protocol. And so for the rest of the half hour for today, I would like us to kind of work on an exercise together, kind of in addressing some of the phenomena I was introducing earlier. Kind of similar to thinking about the traffic lights example, like how do we design the traffic lights of the agentic world, right? So let's say that if a green light lets us cross a busy street with confidence, along with many other protocols which you've listed, what signals or rules will guide trust when intelligence is everywhere? Right? The task here is to imagine a near future city where intelligence is distributed in cars, buildings, households, robots, street sensors, AI agents that negotiate on your behalf in the digital world. So the task is to work in groups and think about the trust protocols that keep everyday life safe and smooth. So the kinds of questions I want us to consider here include, so how do humans recognize and feel that an agent is trustworthy? What are the kind of technical primitives, the governance recourse mechanisms, rituals or signals that we have to think about in order to guarantee that, the correct behavior in handling failure and disputes or making these assurances visible in everyday life? And lastly, like how do we think about, failure and evolution? So what happens when the protocol is attacked or norms are shifting? Like how can we adapt, right? So I've thought of, just simply six different areas that we can, potentially create hypothetical kind of scenarios for. So including autonomous mobility, so designing trust for roads, let's say full of self-driving cars and drones. We can think about the setting of domestic robots, right? So what if, we begin to have kitchen robots or elder care robots? How do we know that they're safe and working correctly? We already see AI finance agents, right? So agents that invest and negotiate on our behalf 24/7. And the other three examples include smart buildings and cities. If we think about these objects like IoT, like doors, elevators, energy grids that can think for themselves, how do we ensure their trustworthiness? Health and bio agents, so AI triage doctors, let's say gene editing nanorobots, right? You can get pretty creative. And then lastly, if anyone's interested in working at a planetary scale, planetary coordination like swarms of, let's say, climate control satellites or ocean cleanup robots, like how do they coordinate and what kinds of protocols do they need? Okay, so I've created a mural board. We can all kind of get into these breakout rooms and then co-work for a little bit before convening. But in your mural board, I've kind of just listed some, different components to work through, including, specifying, first of all, by picking an area, and then you can specify what exactly the scenario you're working on. So you can, simply put that in one sentence. List the actors, right? So who are the kinds of people or AI or, other stakeholders involved in this scenario. And then the next step is to map out the user journey. So with this scenario, what exactly happens, right? So what happens at each step? What are the key actions? What's the data input, output, and the kinds of decision that's made? And then with that, for each step, also note the potential risks, right? What could possibly go wrong? Is it, lack of consent or operational failures, misalignment, etc.? And then with that, at each step, what are the necessary protocols that we need? And you can think about both technical and social ones, the examples that we've seen. And then the last three, think about the governance and recourse, right? So describe the oversight mechanism. What about dispute resolutions and what kind of incentives or penalties that, we might be building into the system? And then the sixth one is thinking about rituals and signals. So what are the visible or experiential kind of trust cues, right? Do you have to, so at the, felt experience level, like what are the symbols or kinds of, visual cues that signify, whether things are working or not working? And then finally, if there is time, think about evolution, right? So explain how, trust will be adapting over time. Like how do you upgrade rules? What are the, reputation decay, etc., other things that we need to think about kind of evolutionally. Okay, so I'm gonna stop sharing my screen and maybe we can, with the help of Timber, like organize folks into breakout sessions.
Yeah, so I think we'll do 6 rooms, which will be between 5 to 6 people per room. But I noticed that there are 6 scenarios. At CPunk protocols, there are like a dozen people. Should they make two
Mhm.
more so that there are 8 scenarios?
Yes, yeah, yeah.
Okay. So
Yeah, they can just copy that role or I can do that. So the link, okay, let me just copy the link. Okay. Oh, wait, sorry, that's not the right link. Okay. Yeah, it's quite a long link.
I'll put it in the Discord too.
Yeah.
Okay, I just made the rooms. Everybody good with instructions? Then yeah, maybe post the slide with the instructions in Discord and everybody should be ready to go. How long do you want the breakout room to go?
Maybe give it 20 minutes and then we can have, several folks to share in the last 5, 10 minutes or so.
Okay. See you guys in 20 minutes. I shuffled some people around, so we actually just have 5 rooms.
Okay. Yeah, I'm just reading the chats now because I couldn't see anything. Couldn't see people while I was talking, but yeah, looks great.
Yeah, there's a lot there.
All right. Yeah, welcome back. And thanks everyone for participating. I know we only have a couple of minutes left. So why don't we maybe have go around the room and have maybe folks introduce what they were working on and what were some of the highlights from each team.
Quickly on the case of elder care is particularly interesting because we in the case of cognitive disability, or decline, we don't know that they can check the action of the AI and that they can verify if the AI makes a mistake. So that adds a layer of challenge to the general verifiability, explainability. What's the point of explainability if they can't understand the explanation? So you have to make it extra visible, both the reasons for the action and the trace of already taken actions. I'm notoriously, I don't believe in human in the loop. They're always overworked. So it becomes rubber stamping.
Yeah, so who would be doing the checking? Would it be other AIs also kind of
Which
counter
are
checking?
subject to the same limitations. I didn't get into this, we could get into a kind of AI quorum. I'm not particularly impressed by this. I think that I don't believe in using AI for this. I believe in using classical algorithms, which can be checked, and with an escalation system, so that whenever there's an exception, you can start reasoning about, can we make that exception part of the protocol so that people in charge of handling exceptions have the least work and can spend the most work on understanding the exception when it's still an exception.
Awesome, thank you. Yeah, what about any other like the governance or evolution of these kind of protocols? Has the group gone in discussing those?
In a way, what I'm saying about exceptions, like incorporating the exceptions into an algorithm, is
Yeah.
part of the evolution. The
Mm.
governance, we didn't get into that so much, but I do think that making it visible allows for global governance. We did get into the fact that the specs of what is expected also need to be public, explainable, and so on, so that whoever makes a choice can have access to, and those should be ideally converge. The set of specifications and requirements also need to be visible and
Yeah,
converge.
that's awesome. Thank you. Yeah, should we invite the CPunk folks to share?
All right, you guys ready to share? Any volunteers? It's 1 a.m. here. I don't know if someone's going to step up. Just reflect on just summarize your experience. Maybe someone from the group. Sorry, there's a little low energy in that group right now. Yeah, okay, there's someone coming. Let me get the camera on as well. Sorry, guys. It's cabled right now, so you should come up.
Hello. Yeah, so we talked about smart cities, and I guess we started from kill switch, and we weren't too sure how to kill it. Maybe like erasing all the memories, but yes. And also, we didn't want to shut down the whole cities. Maybe, and at the same time, we can decentralize the agents, right? So we don't centralize everything to one agent who can get rogued or get hacked by our competing neighbor city. So maybe we divide the cities into blocks, and then each block has each AI mayor agent. Yeah, governor. Yes. Yeah, I think that's it. Yep. Thank you.
Smart City Expo early this afternoon, stuff that inspired some connections. Thanks, Helena. Back to you.
Okay. Yeah, I'm curious. So because you mentioned that it can be deleted, but if it's decentralized, does it still have the centralized control for the data?
They're thinking really hard.
Okay, it's late. It's
They
past.
will get back to you with answers. Yeah.
Okay, okay. Yeah, there's
Not
also
think that
homework,
far.
so opportunity to
It's
continue.
homework. You guys have homework. Yeah. Thanks.
Invite another group to share for maybe the
Yeah.
folks who are
Yeah, hi. We're group 4 and we're supposed to do smart buildings and cities. Especially we did something on the energy grid that thinks for themselves. We're talking about the energy grid at the size of a community power plant that generates renewable energy for a rural community. And as the grid mix is transitioning like from fossil fuels to renewables, but the tension occurs between having renewables as the main energy source versus having some clean new energy fuel. energy field that is carbon neutral in the future. So for an attacker, the benefit of attacking such a system of power plant and local energy grid would be to perhaps first gather the information of all the users that within the rural community. Or another plan of attack would be to decrease the effectiveness of renewables, or in order to present a favorable outcome for clean energy fuel. And then that would benefit some party over the others, for example. So we didn't delve into the solution of this very much because we don't have the time to do, and we don't have the technical capability to discuss about the existing grid protocols that does this. But we identified a few vulnerabilities in the systems, which might come from updating the software of the AI agent itself and updating the peripheral software of the energy grid. If other AI agents have the ability to inject some code that alters the behavior of the power plant such that they operate suboptimally, and then that will present what the attacker wants, essentially, which is the unfavorable outcome for the renewables. That's pretty much our progress here.
Awesome. Thanks so much for sharing. Yeah, that was a lot of content already that came out of this very short working session. Yeah, I think the solutions would be, otherwise for a whole semester. Thanks so much for sharing. Is there another group that would like to share?
I'm okay to share. So our group was group 5, and we discussed basically agents doing robotic surgery. And there's a tension between, so basically our worry is you go in because you have a collapsed lung, and then you come out and one of your kidneys was removed. And this was because the agents that were working on you, the AIs that were doing your robotic surgery, decided that the necessity of your kidney for somebody who is dying of kidney failure in the operating room next door sort of superseded sort of your personal thing. And there's some complexity here because today we can't really interrogate these AI systems because they're opaque. And so the tension there lies between the micro and the macro. So that's sort of the idea. And I know we've talked about that in a general way for some of the other groups. And so I wanted to animate it with a personal story. A few years ago, there was a situation where there was a virus that was being propagated from Windows machines that hadn't been patched. And we did a lot of work to figure out where that virus was coming from, and eventually identified that it was coming from a hospital, specifically an MRI machine. And so you go to the hospital's IT admin and say, hey, man, you got to update your Windows machine because it's infecting other computers, and otherwise we'll just do this remotely for you. And he says, I can't, because the software update is not FDA certified. And so there's this entire protocol in a different context where you might know that there's a problem with your robotic surgery system, but because of the economic inefficiency of spending $100 million to go through phase 1, phase 2 clinical trials to sort of recertify your MRI machine, you can't actually apply the software update. And I think that particular example got solved, but that class of examples is really difficult to deal with.
Yeah. Yeah, super important but difficult problem to solve for. Do you have another group that would like to share? Yeah, Pati.
So it's actually related to that. In fact, initially we were planning to do the planetary swarm one, but then we saw it taken and there was some interest in the health one, so we decided to do both and think of bioswarms, and they can be in both levels. For example, we can think of them as acting at the level of white blood cells, T cells, like immunity, based on a sequenced DNA, but they can also be acting as an actual swarm, where it's like a modular ambulance where it just goes into your place, gets you, so that a whole ambulance doesn't have to come. You're like the swarm. We're thinking of this kind of completely decentralized, very automated health system that is almost the opposite of a public health system. And how that would work could be how to say, of a subscription-based model where basically you have the sequenced DNA and basically you have trusted parties that offer these swarms that provide these health services of all sorts. And then there's all kinds of issues with that, obviously, especially with sequence data. So they can be sequence data can be acting in a trusted in a TEE where the agents have access to it, and then they get personalized to a specific person. Then Mike had some interesting things from his collaborations about some modified Hippocratic oaths, where they're not just based on like classical profile, but like some values based on the network of people that are involved with the services. So yeah, I think that's how far we got with our own wild imaginings.
Great. Thanks so much for sharing. Yeah, we can definitely like continue these conversations on Discord as well. Do we have another group sharing, or was that pretty much all the groups? Timber, yeah, I lost track of how many groups there are and how many people share.
That was about it. Yeah.
Great. So I have one more slide for homework. I mean, yeah, just in case anyone wants to think about this more, but I'll just pull up my screen again and then share that slide with you all. Okay. Okay, so this would be like a kind of hypothetical homework I would maybe ask the students to work on for the first week is essentially basically create some kind of trust experience watch where I want kind of us to get into the habit of start to observing, analyzing, noticing both the visible and invisible kind of trust protocols which make our daily activities possible, right? Because I think like at this point, most things we do has become infrastructure in a way. Like we don't think about them, but actually before they became infrastructure, there was always a moment when, new protocols were introduced because we're thinking about, these kind of new scenarios, new protocols, but there is a process of how they become, institutionalized and normalized. And so the assignment would, entail picking maybe just two everyday situations where you experience, let's say like even this week, just doing something very mundane. And then for each situation, map the kind of the trust stack. So either, the physical, material, kind of mathematical, institutional, social, like the ones that we've seen in the lecture. And then reflect on, where do you see gaps or single points of failure, and how might these protocols need to evolve as we encounter kind of AI and autonomous agents becoming common, right? So even with crossing the road, right now we're just looking at, signals, traffic lights, etc. But what if everywhere there are autonomous cars, right? Like the protocols in which we follow, either the cars just adopt to our existing protocols, but are they enough or do we actually have to adapt them as well? So think about these issues within kind of the framework of thinking in terms of the future. So yeah, that's my email on the screen for anyone who wants to connect or just continue the conversation, or if you have any ideas or thoughts, super welcome to stay connected. And yeah, thank you all for joining and for the lively discussion on Discord. I was surprised to see, I don't know, what looks like hundreds of messages. Yeah, and all of your participation in the exercise. All
Awesome.
right.
Thanks, Helena. Next class is at 1 p.m. Pacific time, and we also have a memory SIG call in about 15 minutes. So you can hop into that if you're interested in SIGs, which is how you can continue to participate after the school is finished. Nice job again, Helena, and we'll see everybody on the Discord.
Okay, bye.